I'm going to be solving from Chapter 7, Section 5, number 15. So this asks us to solve the equation tangent of theta plus 1 is equal to the secant of theta. Now this looks an awful lot like our fundamental identity that we can find on the back of a book, which says that 1 plus tangent squared of x is equal to secant squared of x. So we have to think if there's a way that we can make this equation look like this identity. And a way we can do this is by squaring both sides of this equation. Alright, so we square both sides and we end up with this. Tangent squared of theta plus 1 plus 2 times the tangent of theta is equal to secant squared of theta. Now, we can use this identity, and we can say that tangent squared plus 1 is equal to secant squared of theta. So we can substitute secant squared of theta in for tangent squared of theta plus 1, and that gives us secant squared of theta plus 2 times the tangent of theta is equal to the secant squared of theta. Now, we can move the secant of theta squared over here by subtracting it. And when we subtract it, this will end up equaling 0, and this will cancel each other out, and we'll just be left with 2 times tangent theta equal to 0. Now it's pretty simple to solve for theta. We divide 0 by 2, and we divide this side by 2, and that just equals 0 again, so we just are left with tangent of theta is equal to 0. And then we take the tangent inverse of 0 to get theta, and you can put that into your calculator, and what you're going to find is that the theta is equal to 0 radians. Now, the only time that that value of tangent is going to happen is at 0 radians. There's no other spot other than when it's repeated after it goes around full circle. So that's when we add 2 pi, which is like 360 going all the way around the circle. So to really encompass all our answers, we have to write 0 plus 2 pi k, where k is any integer. And then since it's just a 0 out here, we can just get rid of that 0 and just have 2 pi k, which is our answer.